We're now going to look at special angles in the unit circle outside of the first quadrant. I've written here, you'll see on our first page, I've written the unit circle along with the coordinates for the angles in the first quadrant. That's 30 degrees, 45, and 60 degrees. And again, the denominators are all 2, and then counting down from the top, that's 1, 2, 3 on the top, and then going back up from the x-axis, 1, 2, 3. So these are the only 3 coordinates you really have to memorize for the unit circle and to know what all of the values of the special angles are. So we are first going to learn how to locate where the angles are outside of the first quadrant, and then we'll talk about how to find the trig values of those angles. And we're first going to focus on radians, and then we'll move to degrees. Because actually radians are easier, I think, to locate than the degrees are. So, radians. Alright, so I want to locate the angle 7 pi over 6. I don't want to know what I'm not looking at the trig functions, I just want to locate this angle 7 pi over 6. Okay, so to locate the angle 7 pi over 6, essentially I need to know which quadrant that falls in. So here's what I'm going to do. I'm going to first realize that halfway around the circle here is pi units, and then back up the rest of the way. So halfway is pi, and then the rest of the way around gets you over here to 2 pi. So what I'm going to do is look at the denominator here of my angle. The denominator is 6. So I'm going to write pi, instead of writing it as 1 pi, I'm going to write that as 6 pi. Because 6 is the same thing as 1, and so 1 pi would be 6 pi. The same thing for 2 pi. Instead of writing it as 2 pi, I'll write it as 12/6 pi. 12 divided by 6 gives you 2 pi. So I look at the denominator of the radian angle I'm given, and I write pi and 2 pi in terms of that denominator, 6 and 12/6. And then I look at the angle that I'm given, 7 pi over 6. Well, 7 pi over 6 is just a little bit more than 6 pi, so I know that that angle has to be down here in the third quadrant. So this angle measured around here is 7 pi over 6. Okay, let's try that again. Let's try 5 pi over 3. Okay, and again, I'm just locating these angles. I'm not talking about the trig values of these angles, I'm just locating them. Okay, so halfway around is pi, all the way around is 2 pi. Okay, I look at the denominator is 3, so I want to write 1 pi as 3/3 pi, same thing as 1 pi, and 2 pi as 6/3 pi. 6/3 pi, 6 divided by 3 is 2 pi, and that's equivalent. Now, I look at my angle again, it's 5 pi over 3. Well, 5 pi over 3 is just a little bit less than 6 pi over 3, so that angle must be in the fourth quadrant. So this angle measured around in this direction is 5 pi over 3. Okay? How about 3 pi over 4? Pi over 4. Okay, so halfway around is pi, all the way around is 2 pi. I'm looking at force here, so I write that as 4/4 pi. That's 1 pi, and my 2 pi, I write it as, let's see, 4/4 would be 8/4 is the same thing as 2 pi. 3/4 is a little bit less than 4/4, so I'm going to locate that angle in this quadrant. Okay, so that's what you need to know to locate those angles. Now, once I've got those angles located, now because of the symmetry of the unit circle, I can now take a look at those trig functions. So, for example, let's take a look at maybe the sine of 5 pi over 6. Okay, so here's the idea. I'm thinking again of the unit circle, radius of 1. So on the unit circle, if I want to know what the sine of 5 pi over 6 is, I'm only interested in what the y-coordinate is. Okay, now first I'm going to do is locate the angle 5 pi over 6. So halfway around is pi, all the way around is 2 pi. That's 1 pi then would be 6 pi. 2 pi is 12 6 pi. I'm going to first locate my angle 5 pi over 6. That's in the second quadrant. Okay, so that's 5 pi over 6. Now remember those coordinate definition, the coordinates on the unit circle for a pi over 6 angle. Those are the same coordinates you want here. Since 5 pi over 6 is a multiple of pi over 6, I need exactly the same coordinates you had for the pi over 6. The only thing that's going to change is that in this second quadrant, the signs are different. That is, the SIG ends, positive and negative, are different. So for a pi over 6 angle, if you recall, the coordinates were, let's see, square root of 3 over 2 and 1/2. But since you're in the second quadrant, y is positive, but x is negative. So the actual coordinates are negative square root of 3 over 2, comma 1/2. Now, since I want the sine of 5 pi over 6, I only care about what the y value is. The y value is 1/2. So the sine of 5 pi over 6 is 1/2. Okay, let's try this again. Let's do the cosine of 4 pi over 3. Okay, so the first thing we need to do is locate the angle. I'm going to draw my circle in here. Halfway around is pi. All the way around is 2 pi. I've got thirds, so I'm going to write that as 3/3 pi and 2 pi as 6/3 pi. 4/3 pi is just a little bit more than 3/3, so I'll draw that down here in the third quadrant. And I need the coordinates for the pi over 3. That's what we're looking at here, is a pi over 3 angle. So let's see, coordinates for a pi over 3 angle are 1/2 and square root of 3 over 2. And in this quadrant, it would have to be negative 1/2 and negative square root of 3 over 2. Okay, so now I'm thinking cosine of 4 pi over 3 is simply the x-coordinate, which is negative 1/2. So the cosine of 4 pi over 3 is negative 1/2. Okay. We'll try another one, I guess. How about the tangent of 7 pi over 4? Tangent of 7 pi over 4. Okay, so first locate the angle. Draw my circle. Halfway around is pi, all the way around is 2 pi. I've got fourths as my denominator, so that means that's 4/4 pi, and over here is 8/4 pi. And so 7/4 pi puts me down in this quadrant, in quadrant 4. And I'm thinking about a pi over 4 angle this time. So pi over 4 has coordinates square root of 2 over 2, square root of 2 over 2. Adjust the signs for the fourth quadrant. That would be positive x, but negative y. So therefore the tangent of 7 pi over 4 is the y-coordinate over the x-coordinate. So that would be negative square root of 2 over 2 divided by square root of 2 over 2, which is simply negative 1. So the tangent of 7 pi over 4 is negative 1. Okay, now we're going to do the same thing with degrees. Okay, so let's practice locating, and then we'll go ahead and look at the trig functions. So let's locate an angle of 210 degrees. Okay, so halfway around is 180. Down here is 270. So 210 then has to be in this third quadrant. Now, it's going to turn out here when we look at the values of the trig functions for 210, we're going to need to know something called the reference angle. And what the reference angle is just the angle that's measured up to the x-axis, always to the x-axis. So if I have a 210 degree angle, then this angle in here, the reference angle, has to be 30 degrees, because 210 is 30 degrees past 180. And that's going to become important to us when we start to write down the trig values for these degree angles. Okay, so let's try another one. How about 330? Okay, so halfway around is 180, all the way around is 360, so 330 must be down in this quadrant, in the fourth quadrant. And again, we're going to need to know what this reference angle is. You always measure it back up to the positive axis. If this is 330, then back up to the positive, or to the x-axis would give us 30 degrees. So the reference angle here is 30 degrees as well. Okay, we'll try one more. How about 120 degrees? So 180 is halfway around, 90 degrees straight up. So 120 is in the second quadrant. And again, the reference angle measured to the x-axis. So if it's 120 so far, to get down to the x-axis, we need another 60 degrees. So this reference angle in here is 60 degrees. Okay, now let's try to look at some of the trig values for these degree angles. Okay, so let's look at the cosine of 210. Well, as we've seen in those last examples, we know where the angle is located. The angle is located in the third quadrant, 210. I'm going to draw my circle in. Okay, so 210 is located here. That was 180. We said that the reference angle then was 30 degrees. And here's where that reference angle is important. Remember the coordinates for the 30 degree angle? Coordinates for a 30 degree angle in the first quadrant there were square root of 3 over 2 and 1/2. Okay, so that means that in this third quadrant the coordinates are both negative, and therefore if I want to know the cosine of 210, I'm only interested in the x coordinate. The x coordinate is negative square root of 3 over 2. Therefore, the cosine of 210 degrees is negative square root of 3 over 2. Okay, let's go again. Let's take a look at the sine of 330 degrees. Again, we saw in the previous examples that 330 degrees is in the fourth quadrant. I can draw my unit circle in here again. So we're in the fourth quadrant. 330 degrees. We saw before, to go back up to the x-axis makes our reference angle again 30 degrees. So I'm going to write down the coordinates for a 30 degree angle. The coordinates for the 30 degree angle are square root of 3 over 2 and 1/2. I adjust for the signs now in this fourth quadrant. So the first is still positive, but in the fourth quadrant that's negative. Therefore the sine of 330 degrees is negative 1/2. Okay. Let's do the tangent of 120. So tangent of 120 degrees. Okay, so I'm going to draw my circle. We saw the angle was in the second quadrant. That's 120 degrees here, which makes our reference angle be 60 degrees. So the coordinates then, let's see, for a 60 degree angle, 60 degree angle coordinates were 1/2 and square root of 3 over 2. And in this quadrant, x is negative, so that's negative 1/2, but y is still positive. So now when I think about the tangent of 120, that's y over x, and that would be the square root of 3 over 2 divided by negative 1/2. Simplifying, that's the square root of 3 over 2 times negative 2 over 1, or simply the 2's cancel here, negative square root of 3. Okay, and that's our final answer. Okay, so that does special angles in any quadrant, degrees, or radians. Personally, I kind of like the radians because I don't have to worry about reference angles. With degrees, you have to find the reference angle to relate it back to the coordinates in the first quadrant. But using this method, you only have to know what those first quadrant angles are, the coordinates for those, to find any of the special angles. So don't memorize the whole circle. There is no need to memorize that whole circle. Okay, thank you.